All right. All right. Today we are moving on past naming and writing formulas for compounds, and we're going to get into some stuff that starts to look like chemistry, because we're going to talk about balancing chemical equations. And so we're going to work on that here today and tomorrow. So first today we're going to be introduced with the general idea of balancing chemical equations, and we're going to get some practice. And then tomorrow, we're going to add a step so that you are just given the names of the reactants and the products, and then you have to first write the chemical equations and then balance them. All right. So, first of all, this is an example of a chemical equation. Okay. So, a chemical equation represents a chemical reaction. So it represents a chemical reaction. It includes the formulas for the reactants. These are the reactants and products. And these are the products. So the reactants are the things that you're mixing together or go in to the reaction, are forming a reaction is occurring between the reactants, and the products are what you produce or what comes out, what's left over after the reaction has taken place. All right? And we represent the reaction with an arrow like this. All right, so that's how you know that a chemical reaction is taking place. There's this arrow that represents the reaction happening. Another thing that you might notice is that we, in little parentheses, we have the state of matter of each of the reactants and the products. State of matter of all reactants and products are included. So this one's a gas, this one's a gas, this one's a liquid. That's what those are telling you. All right. So that's just kind of the basics of the states of matter. All right. And the basics of what is a chemical equation and how to look at one and tell what we've got here. Okay, and so we could look at it and we could say, oh, we're mixing nitrogen gas with hydrogen gas and we're making ammonia. Okay? So now let's get into actually balancing it. So let me write that equation again. And what I want you to know or notice is if we look at both sides of the reaction, the reactants and the products, let's count up the number of atoms of each element. So here we have 2 nitrogens and we have 2 hydrogens, right? So on the reactant side, we have 2 nitrogens and 2 hydrogens. Let's look on the product side. We have 1 nitrogen and we have 3 hydrogens. These numbers are not equal. So this is not balanced. We can't have a reaction where the number of atoms on one side is different than the other. That's not allowed. Okay? We can't lose atoms somewhere. They can't just go poof and disappear. So what we need to do is balance it, which means make sure that on both sides there's an equal number of atoms of each element. All right? And so what we do to balance, we can add big numbers, which we're going to call coefficients, in front of the reactants or the products. So I could add a big number like out here, or I could add a number right there, or I could add a number right here, all right, to make me have an equal number of atoms of each type on both sides of the chemical equation. Okay, but the important thing is that we multiply all atoms in a compound or element by the coefficient. So, like in my example, if I would put a 2 here, I would need to say now I have 2 times 1 or 2 n's and 2 times 3 or 6 h's. So if I want to put a big coefficient here, I need to multiply 2 by the number of each element that I have. All right. Well, then how am I going to balance this equation? Let me write it again. So the first thing is I'm going to write down how many of each I have on both sides. So I have 2 n's, 2 h's on this side. On the right side I have 1 n, I have 3 h's. Let's switch to another color. So I notice I need, let's pick one to start with. I need another n. I need 2 of them to over here to match the 2 over here. So I can add a big 2 to have 2 times 1 or 2 n's. But doing that also gives me 2 times 3, or 6 h's. So now the ends are balanced. I have 6 h's over here, I have 2 over here. Thinking, is there some number I can put here that I have this times 2 equals 6? And there is. That's 3. So now this equation is all balanced. And so you don't need to put a 1 out in front here if we're not changing this. We're just going to leave it like this. So now this is balanced. All right? Let's do some other examples here. So first I'm going to count out how many I have on each side of each element. 1 and 2 chlorines. On this side I have 1 iron and 3 chlorines. So how am I going to get this balanced? And maybe I will give us some more room to put coefficients up here, because right now there's not a lot of room. So let's see. This is what I'm thinking to myself. I can't put anything out in front of here to make that 3. I can't, there's nothing there's no whole number. There may be a fraction, but there's no whole number that I can multiply by 2 to get 3. So let's think about, is there a number I could put here so that the number of chlorines I have here is a multiple of 2? Well, what if I put 2 right there? 2 times 3 chlorines is 6, and 2 times 1 irons is 2. Can I make me have 2 irons over here? Yeah, I'll just put a 2 right there. And can I make it so I have 6 chlorines over here? Yeah, I'll just put a 3. So now this is balanced. 2, 3, 2. 2, 3, 2. Now what you need to remember is that we're always going to keep our balanced reaction in the lowest form. So for example, if you would balance it and you would have gotten like 4, 6, 4, this is just the same thing as what we got. It's just not reduced. You can divide everything by 2, right? So we're always going to write our answers in the lowest form. Why don't you try these two on our piece of paper on your own, right? So try these, and we can look at those as examples when we get together.